So let's say we want to draw this function out here, y equals x squared plus 2x minus 15. So we're going to have a little graph of it. So I'll put it down in a corner here. And we're going to have our x and our y here. So we'll have an x, our y, and we want to know what this looks like. Now, we already know that it's y equals x squared, so we know that it's going to actually sit like this. So it's going to be a function that looks like that, but we have to find exactly where it's going to sit on this graph here. So we can start off by trying to find where it crosses the x-axis. That is, we're trying to find the roots of this. Now, it crosses the x-axis when y is equal to 0. So we just put that into the function above. So we're just going to have, if we write it around the other way, we'll have x squared plus 2x minus 15 is equal to 0. So therefore we have to go and solve this quadratic equation. So if we take this here, the minus 15, we can create 15 by multiplying 1 and 15 and 3 and 5. And also we can create the x here by just multiplying 1 by 1. Okay, so the x squared created by multiplying x by x. So therefore we're trying to generate this value of 2. So in order to generate the value of 2, you can see here that you can use the 3 and the 5, because the 5 minus 3 will give you a value of 2. So let's try and factorising it. We're going to have the value of x here, and the x, that will give us our x squared. We're going to have a 3, and we're also going to have a 5. Now we want to make the value of plus 2. So what we want to do is we want to add the 5 and take away the 3. And this whole thing will equal 0. So we can just check that. We're going to have x squared minus 3x plus 5x will give us a plus 2x. And then we'll have the 5 times minus 3 will give us minus 15. So we've got here the equation here factorised. So these are the factors. So the actual roots are going to be given by the value x plus 5 equals 0. So x will equal minus 5. And we're also going to have the other one, we'll have x minus 3 equals 0. So we can say that x will equal a value of 3. So we've got a couple of points here in our graph. They're going to have the point, it cuts the x-axis at the point minus 5. Okay, so it's minus 5, so counting along 1, 2, 3, 4, say minus 5. So that's minus 5, 0 is one of the points. The other point is 3, 0, so go 1, 2, 3, 0. Now, this function here, it runs like that, okay? And it's symmetric. So this function up here, if you draw it like that, you can draw a line straight down there, okay? And it's absolutely symmetric, okay? So if this is a point here, and we'll put the point in, so it's going to be 3, 0. And this is a point here, minus 5, 0. Then the axis of symmetry must sit halfway between these 2 points. So the distance between these 2 points is going to be 3 minus a minus 5, which is a value of 8. So the axis of symmetry is going to be 4 away from each of these sides. So if it's 4 away from this 3, then the axis of symmetry is going to sit at the line minus 1. So the axis of symmetry sits down here like this. So now we've got the axis of symmetry, we can find the turning point. So let's go ahead, we'll do that now. So we'll just write down here, turning point. Now, whenever x is minus 1, we're going to get the turning point. So if x is minus 1, what's the y value going to be? Well, y is going to equal minus 1 squared plus 2 times minus 1 minus 15. So that's going to equal, well, that's 1 minus 2 is minus 1 minus 15, which is minus 16. So the turning point is going to be given by minus 1 comma minus 16. Okay, so I'll raise this up because it's going to be a bit further down, so it's somewhere down here. So let's say down here minus 16. Okay, so this is going to be the turning point. Turning point is minus 1 comma minus 16. So it's going to run down like this here, and it's going to cut the y-axis somewhere. So we have to find out where it cuts the y-axis. So the point at which it cuts the y-axis, it cuts the y-axis whenever x is equal to 0. So we can say cuts y-axis when x is equal to 0. So let's go and we'll find that point now. So whenever x is equal to 0, up here, we're just going to put the value for 0 in. So when x is 0, that is 0, that is 0, and y is minus 15. So that means it's going to cut the y-axis at point 0 minus 15. So 0 minus 15 is somewhere around about here. So that's where it cuts the y-axis at 0 minus 15. So we can join all these points together and we'll create the graph of our function. So it's going to run something like, it's just a rough sketch. I'm going to run something like this. So this is the graph of our function y equals x squared plus 2x minus 15. So what we want to do is take this and put it into the graphical calculator and see whether it does actually give us all of these points, and we'll check our work. So let's put our function in. We're going to have y equals x squared plus 2x minus 15. So let's check and see we've got all the correct points. So the root is minus 5, 0, so it cuts the x-axis at minus 5, 0, which was correct, and we've got 3, 0 here, and the turning point is minus 1, minus 16, and the point that it cuts the y-axis is 0, minus 15, and it runs in this direction here. So we've got that one correct. So thank you for listening. I'll get you on the next video. Goodbye.